Hi, welcome to ESP32 tutorial from Robojax. My name is Ahmed Shamshiri. I'm present. In this tutorial we are going to control two DC motors using ESP32 over Wi-Fi with L298N module with Robojax library. Let's start the motor. This is just controlling one motor. Speed up, change the direction of rotation. And now let's start motor 2. Direction of rotation of motor 2. Direction of rotation of motor 1. And to control it using your mobile device, USB is not connected. I can control motor 1. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. Before I start with anything, if you just need the code to run it, you can grab the code and start using it. But if you want to learn, you have to watch this video step by step without skipping. Because many times people ask me questions in the comment. I read all those comments. People ask a question that has already been answered in video and they have skipped. So please make sure to watch the video if you have any question. At my best knowledge, I will not leave anything out. I will try to explain everything. And also I will provide you the link below the video. In my all videos, under the video in the description, click show more and you will see the link directly to different section of the video. You can click on any of these links to jump directly to different section of the video. I've received a lot of requests and interest into controlling DC motors using ESP32, and because I've written library for this L298N module, this is one of the best motor controller module that you can use because it has a heatsink. Even though it's small, but it can handle majority of these smart cars and robotic application. And it can work up to 35 volts, so that's a very good module and also cheaper. So the library is available. You can use it for the Arduino Uno. I have separate video explaining this module with full detail on how to use it, how to control two motors. The link is below this video, you watch it. And also I have separate video explaining how to control these DC motors with this microcontroller ESP32 without Wi-Fi. But in this video we are going to control these motors via Wi-Fi within the same network of your home or organization. It will not work from remote location because there is some setup in your router and finding the IP address, which I might create a separate video for that. You have to be connected to the same Wi-Fi that this will connect. So this will connect to your router, and your tablet, phone or computer will be connected to the same router. It must be the same, otherwise you will not see it. Then you will be able to control it fully. This module can accept up to 30 volts external power, and if your motor is 12 volts, connect 12 volts. If it is 24 volts, connect 24 volts. It will just work fine. If your motor is 5 volts, if you want maximum power, make sure to input here around 7.2 volts. If you use 2-cell battery, it will be perfect for this because the output is not above 5 volts. But this module also supplies 5 volts once you connect your, let's say, 7 or 10 or 12 volts. This is a voltage regulator. It will output 5 volts. I've prepared this screen. This is a bar graph that you can speed up the motor, so it will increase. It will show you if the motor is stopped or start, and it shows you the direction, also the speed. And because the motor is off, here it shows, as you can see, start. And in this case also, this is for motor 2. The same way you can control it, and you can change the direction. If I press CW, you see it's CCW. If I press CW, it will become CW. This is also the same way. And if I want to start it, I will just click and it shows running at this. If it is stopped, so this text also is changing accordingly. Let me now explain the wiring. I've connected this motor, the motor 1, to this point, and this is the motor 2. It has been connected to this side. So this is motor 2, that's motor 1, and these are my 2 wires for external power. And you will connect the positive on this side, the negative at the middle, and from this middle also 1 wire, this brown, goes to the microcontroller, to ESP32 at this point, and you can connect it to any ground that you want. This I've connected to 7.2 volts. When it goes, when motor controls it, the output is approximately 5 volts for the motor, so there is some voltage drop, but this is the regulator. When it gets the voltage, any voltage that you have above 6 volts, you will get 5 volts here. This 5 volts can be connected, this red, I've connected it to this pin. This can power up your ESP32 at the 5 volts. I have separate video explaining how to connect this to 5 volts. Also, it has a 5 volts pin, so this can be connected to 5 volts. In my case, the 5 volts is at this side. Using only 1 motor, you need to connect these 3 wires only, and for 2 motors, all of them, 6 wires. And I've connected this 6 wire using this long wire in here, so, and they're in the same order. On the left, this is enable A, N1, N2, that's input 1, input 2, N3, N4, that's input 2, 3, input 4, and that's enable B. So enable A is on that side, enable B is on this side, where they get pulse width modulation signal to control the speed of motor. So this is for motor 2, the 3 last wire are here for the motor 2, and I've connected them in order. Enable A is connected to pin 19, and then N1 is connected to pin 18 here, N2 is connected to pin 5, they are in the same order, and then N3 is connected here to pin 17, N4 is connected to pin 16, and enable B is connected to pin 4. But you can select any other digital pin that are here. In order to start using ESP32 with Arduino IDE, you need to prepare Arduino IDE for that purpose. You will copy and paste it here. You see it says package ESP32 index.json at the end. So once you paste it here, click OK, click OK. This is telling Arduino IDE where to get the board driver. Click on Tools, and then Board Manager. And here, wait for this to complete at the bottom, this bar graph. And then type here ESP32. You see ESP32 by Espressif Systems. It says installed. In your case, it will not be installed. You will have install button here. Click on it, and it will take maybe a few seconds or a minute. And the installation, once is completed, click close. Now we have to tell Arduino IDE which board you're working with, because the driver is ready. Click on Tool, Boards. This is Arduino IDE, which you will usually work, but scroll down until you see a line below that. All of these are ESP32, and ESP32 rover module is the one that you click and select, and the dot will appear. Now we have to select the port. For that, we have to find out which port we are using. Right click on the start menu, device manager, and you see port. Click on this arrow to collapse it, and mine is using COM port, Silicon Lab. If I disconnect it now, you will see that it will disappear. Connecting it back. So this is COM6. Note that, click on Tool, Port, and you will see COM6 is already selected, and now you can write your program and run it. Now let me explain the code. You need to download Robojax L298N DC motor library, which can work with ESP32 and Arduino Uno. I will provide you the link. Download it as a zip file and save it in your computer, for example in my download or my document, whichever you prefer. After that, click on Sketch, Include Library, add .zip library, and then point it to where you have saved it, for whichever you prefer. After that, click on Sketch, Include Library, add .zip library, and then point it to where you have saved it. For example, if this was inside Downloads, go and then select the zip file, and if this was a zip, click Open. After that, make sure to close all instances of this Arduino and reopen it, so the files are displayed in the examples. Then click on File, Examples, and scroll down until you see Robojax ESP32 DC motor. And from here we have examples that are without Wi-Fi and the examples that are with Wi-Fi. And let's open ESP32 L298N DC 2 motors Wi-Fi. And this is a sketch. The code starts from here. This is the header file, that is a class name as well, using include, so we are including it. Without this it will not work. And here these are the 4 parameters that you set for motor 1 to operate. Channel, we are using LEDC channel from ESP32, so this is channel 0, and for motor 2 we use channel 1, which you will see. And this enable pin is pin 18 and 19, and then N1 is pin 18 and pin 5. L298N needs these 3 inputs, and then for motor 2 as well, so 17, 16, 4, and channel B. So these pins are in the same order on the board, so you don't make mistake when you wire it. These variables are used for controlling the direction. Do not change them, and here do not change these numbers, but you can change this if you want. For example, if you have some kind of arm, robotic arm left, arm right, arm 1, arm 2, and then but you have to replace all these instances in the code as those values. Otherwise, leave it as motor 1 and motor 2. And here this is the line where we can use the code. This line is for single motor, which I'll explain it separately, and here this is for 2 motors. Those values that we have, I have uncommented, so this was commented, uncomment either this one or this one. The difference between the two is everything is the same. We pass in 1 and 2 value, enable A, channel A, that's for 1 motor, 4 parameters, and then 4 more parameters for motor 2 with enable B and channel B, and at the end we have just comma true. When you put this true, when you open the serial monitor, it will print the status of motor. This is a debugging information. Usually you don't need it, but for debugging and preparing your project you might need it, so just put true. Once you're done, you can use this one or simply remove the true, and it will work without those information on the serial monitor, so the resources are not wasted. And these are the parameters for motor 1. You can customize. You can leave them as they are, or you can change them. For example, motor direction, initial direction, if you want it to be CW or CCW, put CW or CCW capital like that. And then the increment step, every time you press these values, and every time you press it, you see it goes from 50 to 60. This is the value because we set it at 10. If you set this to 5 or 1 or 2, so you will have more precise control. Speed of motor 40, this is the default speed. When you open your browser, this is what you see here, the default, either if you can set it at 0 or whatever value you want, between 0 to 100%. And the minimum and maximum is supposed to be 0 and 100%, but the problem with the 0 is that many motors do not start at let's say at 1 or 5 or 10. Some of them start at 20, some of them are 40. So if you want your motor to start quickly, set it at a value closer to the value, so you can experiment with this and see at what value your motor starts. And the maximum also I put it because in some cases you don't want the motor to go at 100% for some applications, so I just allowed you to customize it. If you don't need it, just leave it 100. Motor stop state. High means stop is applied. So if you want the motor to stop at the beginning, set this to high. And if you want the motor to start immediately, set this to low. And we have the same parameters repeated here for motor 2 at the middle. So they're exactly the same, but you can customize all of these. If you're not sure what to do, put the speed at 0 and leave it with 100. And this is the file that is needed to print the page for us. All this information is there, so it must be at the same folder that you save. For example, file, open, you will see that the file.h is here with the same file. So this is Arduino file and this is .h, that's a header file of C++. So we will control, and I will explain it briefly here. I've started the rest of the code. I've customized them by starting from this file, example, and then scroll down until you see ESP32. Under the ESP32 section, it's called Web Server and Advanced Web Server. I started with this and changed it completely. So these are, once you enable your Arduino IDE for ESP32, these are already included. You do not worry about it. And this is my SSID, and this is the password that I use with a router for the tutorial. Once the tutorial is done, I will turn it off, so I'm not worried if you know this password. So SSID is case sensitive. Make sure if you have capital at the beginning, you must put it, otherwise it will not work. And then this is initializing the web server. This has not been used, I just left it like that. And then handle root is where I worked a lot here. So this portion is getting my top portion of the page, HTML page. This page that you see, this is HTML page, and we call it HTML page. And then we concatenate or add content to this at different stages of this line. And we add this for the bar graph, this bar graph value, which is changed automatically, and then we add more contents, more sections, and when the speed changes, these are the value. You see when I say CCW, it changes. So all those texts are coming from here, and after that stop is coming also here automatically. When you press stop, motor runs and then stop, so the text changes. And then handle not found, this was there, I did not change it at all. And then inside the setup, here is a line that is needed. Motor.begin initializes the L298N motor library. This was already there, I did not change it. And this line I did not change. This text I did not change. I put here ms begin. This was ESP32. I changed it to my own text with this. So this will print it for us. And this was already there, and these are the 3 lines that I added. If somebody types /speed, what should it do? If the type is get, go to this function. If it is direction, go to this function, handle motor direction. If it is stop, go to handle motor brake. The rest are the same. I will explain those briefly. And inside the loop, server handle, this will run continuously. If motor 1 stop state is high, which means motor should be brake, so we apply motor.brake, and then we pass the variable for the motor 1 will brake. If that is not the case, if it is not stopped, then we say else motor.rotate. So this is the command that you want to use, motor.rotate, and then we pass 3 parameters: the motor name, the motor speed, and the motor direction. Which direction it should run CCW at 50% for motor 1 or so. And then we do the same thing for motor 2, and then we run motor 2, and then these are the values for the motor 2. And with 100 milliseconds, the loop will continuously execute those codes. Now the function that is handling motor speed is here, and it checks when do is equal motor 1. If I bring my mouse over this, you will see at the bottom here that it shows do equal M1 slower, M1 faster, and also when you click here faster, you will see here do speed / speed question mark do equal M1 faster. If I click on this, it says do M2 faster, motor 2 faster, and slower, and here slower and stop. You see do M1 start, do M1 stop. And if I do for motor 2, also motor 2 start and stop. So this is one was just for speed, and this is for motor direction, and this is for motor direction, motor 1 CCW, and then we have motor brake. If I click here, you will see all the codes, HTML code. So this is the code. If I press Ctrl U, you will see the code that we have. This is the page, the same page has this code here. It starts with HTML document type, and this is HTML tagged at the top, and we have HTML at the bottom, and then body. So these are the elements for HTML, which is out of the focus of this video because it will be so lengthy. And here is the code for motor 1. When you run it, it will print only this portion, so you don't need to see the motor 2 components or controls. It's exactly the same, except we don't have this portion for motor 2, and then the line that says motor 2, and then we don't worry about defining other values, so we just use this one. And if you want the debugging, use this line which has comment true, so comment that out and comment this, and it will print all the text for you. This has not been used, so let me delete it. And here, do not worry about the other values because they will not affect anything here. Just leave it like that. And the rest of the code is the same for simplicity. I will not spend time on that because I explained it with 2 motors. Now to demonstrate it, we have to have this machine must be on the same Wi-Fi network as this module. If this is connected to specific SSID, that machine should be connected to the same, otherwise you will not be able to control it. Let me demonstrate it with 2 motors. The code is already loaded. Now if I open the serial monitor, and press this reset button, when I press it, you will see all the details about the board, and it will show you the IP address, so we can access it via this address. This is the main address, but this will not work in some cases on your mobile device, but so you will try this. If it doesn't work, we go through this 192, and here the address that I go is Robojax ESP32. This is with HTTP at the beginning. You type HTTP, and I press enter. This is the screen, and this control is for motor 1 button, and slower. When you press it, the speed will increase. As you can see, it shows stopped. At the moment the motor is stopped, but the direction is set at CCW at 70%. I can change the direction, it becomes CW, and it's still stopped. So this, before you're turning it on, you know which direction it rotates, and then if you press it, it will start running. The text also changes. It will tell you what is going on. And if you want to change the rotation direction, you can press it directly or stop it. The same can be true here for motor 2. As you can see, motor 2 is now running. And now if I refresh, it will bring the values that we have previously set. So you can start both motors together at the same direction. Now input is 7.2 volts and my power supply here to get 5 volts at the output, so there is some voltage drop here. And when I went at 100% duty cycle, it was 1.7 ampere both at 7.2 volts at the input. This will not be valid for every motor. This is the specification for these motors that are used in smart cars. Now the code have been loaded for one motor. I'm not disconnecting the wires, but in case if you want to just run one motor, you can connect one motor only on this side, and it can be only motor 1. So you will connect it here and we call it motor 1. This can be disconnected, and out of these 6 wires, the 3 wires will be connected. So let me just test it so you can see the same way. You can see the motor is stopped. The direction is clockwise and at 60%. And if you want to run it, just run. Motor 1 will start running, and you can change the direction. And stop it. And if you go faster, let me go 100%. Now it's at 7.2 volts at the input. You get 900 milliampere for one motor. So for 2 motors, just double the current. Now if I open the serial monitor and press this reset button, when I press it, you will see all the details about the board, and it will show you the IP address. So we can access it via this address. This is the main address, but this will not work in some cases on your mobile device. But so you will try this. If it doesn't work, we go through this 192. And here is a demonstration of controlling one motor using your mobile device. Now let me test it with a mobile device. We have to be on the same Wi-Fi as this SSID of the ESP32. So I will select my Wi-Fi by connecting to Robojax. Let me connect to Robojax. Now I'm connected to Robojax. I'm typing the IP 192.168.1.102 and enter, and this is the screen that we are getting. As you can see, the text is so large it cannot be viewed here. I purposely set that very large, so let me rotate my phone, and now it is viewed better. Just continue like this. If I press it, as you can see, the bar graph increases and it shows. So this is responding. Now if I start motor, let me go, it's 80%. Now the motor is running. I can change the direction. As you can see, it's perfectly responding. I've loaded the code for 2 motors now. Let me just refresh the page. And here, as you can see, now we have the control of motor 1, and this is the control of motor 2. If you want to see them larger size. So we can go here, and that is control of motor 1, slower, faster. This is a bar graph for it. So, and then the stop, which will turn also to stop, CW, CCW, and that's a control for motor 2. I will rotate it so you can see it on the screen better. Let's turn on the motor 1 that's motor 1. Speeding up, let's change the direction. And then now let's go motor 2. Motor 2 started. Motor 1 stopped. Or change the direction. Or both of them stop. Let's start and start. Let's go 100%. Now both motors are running at 100%. External power is connected here, as you can see, and the light is on. And from this point we have 5 volts output here. Without USB, I'm connecting it to V5 here at this pin, V5. Now this is connected, external power is also connected. And let me refresh the page. Now the code is loaded for 2 motors, USB is not connected. I can control motor 1 and as well motor 2. So as you can see, you can run it without external power from the 5 volts of this. Thank you for watching a tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. And if you're my subscriber, I always try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe.